Hello, welcome back to part 2 of section 4, where we're going to continue to discuss linear functions and vocabulary terms like domain, range, constant functions. I'm going to introduce at the end of the lesson something called a step function. Pretty important concept, something that is kind of difficult at first. Once you get the hang of it, it's not that bad, and it's something that any pre-calculus student should be comfortable with. Okay, so I've given you here a domain and a range where each element in the domain gets mapped to the same element in the range. That is 4. There's only one element in the range. Let's sketch a picture of what that would look like. So, 1, 2, 3, 4. 0 gives us 4. And 2 gives us 4, and 4 gives us 4, and so on and so forth. It ends up being a horizontal line, where the fixed value is the y value. In other words, this is the line y equals 4. In fact, any horizontal line will always take on this form, just y equals some constant number. Now, the nerdy way to put it is f of x is equal to 4. If you had a vertical line, then it would be x equals some number. And the way that I always remember this is a y equals line goes through the y-axis. An x equals line would go through the x-axis. Okay, we call this function a constant function because the y value is always the same. In other words, it's constant. Y stays the same. So for instance, what if I said, okay, here's a function. What is f of 2? In other words, when you plug in the 2, what pops back out? Well, it's 4 because the output is constant. What's f of 3,236? In other words, if you were to go all the way over here, I'm down in the right-hand corner. If you were to go out 3,236 little tick marks, what would the output be? What would the y value be? Well, it would still just be 4. It doesn't matter what you plug in, you will always get 4. That's why it's called a constant function. So here you go. In example number 1, I want you to sketch the graph of h of t equals negative 2. Now remember, h of t is really just some cute way to say y. That just says y equals negative 2. And what did we say about y equals some constant? They're always horizontal lines. Go down 2 and chung 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 chung. Sketch the graph. There it is. Beautiful. That's h of t is equal to negative 2. Now notice something here. The slope m is what? The line doesn't go up, the line doesn't go down. That means the slope is neither positive nor negative. Well, the only number that satisfies those conditions is 0. The slope is 0. You can think of this as y equals negative 2, or if you're feeling cutesy, you could think of it as y equals 0x minus 2. That is slope-intercept form. So the question is, in part B, what's h of 12? In other words, go out 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 tick marks to the right. At x equals 12, what's the value of y? Well, Mr. Williams, this is just a constant function, and it's constantly negative 2. So h of 12 must be negative 2. Nice. In part C, it's not really related to part A or B. I want you to sketch the graph of g of x equals negative 2x plus 4. That's a linear function that starts out at 4, big old dot, and its slope goes down 2, right 1, down 2, right 1. Let's play connect the dots. Ding, ding, ding. That's a pretty little graph. Now, the important thing that I want you to notice here is this dot right here. That is called the 0 of a function, because that's where it crosses the x-axis. It's the value of x such that the function is equal to 0. A little definition that I want to put here. The 0 of a function could also be labeled as the x-intercept, where it crosses the x-axis. And I want you to write a sentence there. If f of x, if the function is equal to 0, or in other words, if y equals 0, and remember, y is always 0 on the x-axis. If f of x equals 0, then x is called the 0 of the function. The 0 of the function. So tell me what the 0 of this function is. In fact, let's do that in the next slide. And looky here. What dot did we circle? Oh, Shuggy. That looks like x equal 2 right there. Nice job, folks. Here's the same function, g of x equals negative 2x plus 4. Tell me what the 0 is. Now remember, what did I say? I said x is the 0 when f of x, or in this case, g of x, is 0. So let g of x equal 0. Now remember, that really just means y equals 0. So let's just plop a 0 right there. So 0 is equal to negative 2x plus 4. And now all you do is solve for x. So minus your 4. Boy, this is difficult, isn't it? All this algebra. And divide by negative 2, so x is equal to 2. Check it out. That means 2 must have been the 0 of the function. Okay, what is the 0 of w of x equals negative 4? Well, first off, you're going to ask yourself what that even looks like. W of x equals negative 4, so it's just a constant. This really just means y. I think Mr. Williams said that constant functions always are horizontal lines, and this one would be horizontal at y equal negative 4. Okay, so we sketch the graph. Well, this is our x-axis, this is our w of x-axis. Where does this blue line cross the x-axis? Where does this blue line here cross the x-axis here? Well, they're parallel, they don't cross each other. So what's the 0? Well, there isn't one. So we would say there's no x-intercept. Or there's no 0. Yeah, well, if there's no x to solve for, then there can't be a x-intercept. Okay, that's kind of cool. Your book will do that to you. It'll try to trick you. Alright? It'll ask for an answer when there's really no answer. Okay, so don't let them trick you on that. Alright, let's jump to number 4. Let's read through this one. Okay, the 0. Think about that. That means the x-intercept, where it crosses the x-axis. The 0 of a linear function is 3. Linear function f. Now, don't let that confuse you. Sometimes instead of f of x, the book will just say f or g. Alright? So that means that our x-intercept is 3, 0. Might want to make that note there. Okay, that's the x-intercept. That's where it's going to cross the x-axis. I'm going to even begin to sketch that down here. 1, 2, trace. Boom. Got to my 3. Alright, let's keep reading. The graph intersects the vertical. Remember, vertical just means up and down. Axis at negative 2. At y equal negative 2. So go down to 1, 2. Big old dot. And it said it's a linear function. That means this is going to be a line. They said find an equation for f of x. Well, now that we got a picture, this isn't too bad. Remember, we need two things. you need M, and you need B, or K, depending upon which formula you're using. And this is in slope-intercept form. Y equals mx plus b. Let's find m first, algebraically. This point is the point 3, 0. This point is the point 0, negative 2. Remember, you do y minus y, so negative 2 minus 0, over x minus x, 0 minus 3. Negative 2 over negative 3 is really positive 2/3. And you could have just told me that by looking at the rise over the run, up 2 over 3. And now find the y-intercept. Oh, wait a minute. We don't need to find the y-intercept because they gave it to us. It's right here. It's negative 2. So m is 2/3, b is negative 2, and our equation, f of x, is equal to m 2/3 x minus 2. Ding, ding, ding. Perfect. Nicely done, folks. Very good. Okay, so continuing on here, a few word problems I want to do with you. Ashley's mom pays $200 a week to rent a dog wash or a dog salon. She charges $5 for each client to come in and wash the dogs themselves. In part A, you want to express the net income as a function of the number of dog washes purchased. The net income as a function of the number of dog washes. So instead of f of x, we need to express income. I would say you use I. Now, income is dependent upon the number of dog washes. I'm going to call that N. You can call it whatever you want. So, income is directly dependent upon number of washes. That makes sense? In other words, the more washes that clients do, the more income she gets. Alright, so she gets $5 for every dog wash. $5 for every dog wash. But wait a minute, her income started out in the negative. Why is that? Well, because she pays $200 a week just to rent the salon. She starts off $200 in the hole, folks. So that is a function in terms of a function of her income in terms of the number of dog washes. And the next question is, when does she make a profit? In other words, when does she break even? Now you can think about this in terms of a sketch. Here's the x-axis, or in this case the n-axis. Here's the y-axis, or in this case the I of n-axis. Okay, the equation would start off down here at negative 200, that's the y-intercept. And it would slowly rise 5 and run 1. And this is right here, that's the 0. That's the break-even point. That's when she has gotten all of her $200 back, and then after that point, she starts to make money. So here's the question. We want to find the x-intercept. So let's remember how to do that? Let your function equal, let me erase that. Let your function equal 0. Or in other words, let y equal 0. So 0 is equal to 5n minus 200. Solve that for n, and you will get 40. So at 40 dog washes, she break even, which means anything greater than 40 dog washes, I'll just put washes, she will make a profit. And that you probably could have done that in your head, relatively simple, relatively easy. Real quick, let's do the domain of the function. Now remember, the domain is the x variable, or in this case the n variable, which is the number of washes, the number of dog washes that she gets. It's all n's such that n, in order to make, or what could the domain be? In other words, how many washes could her clients do? Could you do negative washes? Is that possible? Yes or no? Could n be negative? I actually shouldn't have drawn this arrow right here. No, you can't. You can't go back in time and take back a dog wash. So n must be greater than or equal to what? Can you have 0 dog washes? Well, I suppose you could. It's not good, but I suppose you could. And then her range is the income. In other words, it's the y variable, the up and down variable. And what could her income potentially be? Now let's get nerdy here. All I of n such that I of n must be greater than or equal to what? What could her income potentially be? What could her income potentially be? Well, let's say that she doesn't get any people to come in and watch the dogs. Well, she doesn't make any money at all. In fact, she loses $200. All right? Where I of n must be or is equal to multiples of what number? Remember, how much does she charge for a wash? She charges $5. So could she make, negative $199? No, even if she gets one wash, she's up to negative $195. So I of n must be multiples of $5. Okay, and yes, you do have to make that specification. Okay. That won't happen very often. That's kind of an oddball problem, but it is important for you to distinguish that particular detail of the range in this case. And real quick, I thought I'd show you, just since we're talking about dog washes. Well, let me get rid of this stuff. Get rid of that stuff. Here's my dog Clark at his last dog bath. Shaking it off. And here's my dog Addie. She looks a little bit happier at the time at her last bath. So I thought that was pertinent to the problem that we just did. Okay, and finally the last problem, and this is a pretty difficult problem. You're going to want to follow along closely. Okay, it costs 50 cents for the first minute and 20 cents for each additional minute, or fraction thereof. That's important. You might want to underline that. So 50 cents for the first minute, 20 cents for each additional minute, or fraction of that minute. So as soon as you pass 1 minute, you're going to pay 20 cents. Even if you just talk for 1 minute and 1 second, you got to pay another 20 cents. You have a 30-minute calling card. This problem is kind of out of date, I know, but give an equation for the function and graph the cost of a call for 4 minutes. So let's go time, and instead of f of time, we're going to use c of time. So it's time and the cost in terms of time. So anything between 0 and up to and including 1 minute, how much does it cost? Well, that's 50 cents. But as soon as you get past 1 minute, and you up to and include 2 minutes, how much more do you got to pay? You got to pay your original 50 cents plus 20 cents. And that's actually 70 cents. What if you're between, as soon as you go above 2 minutes and including 3 minutes, you got to pay 50 cents plus 2 sets of 20 cents. Well, that's 90 cents. All right, what if you're between 3 minutes up to and including 4 minutes? Well, now you got to pay your original 50 cents plus 3 times 20 cents. That's $1.10. Well, do you have a function here? Can you think of a function? Yeah, you could say that, well, the cost in terms of the time is equal to the original 50 cents plus 20 cents per t. Does that make sense? So what we're going to do now is attempt to actually graph this function. Okay? And now remember the title of this function. It's called a step function. The actual term is greatest integer function, but for right now we're going to call it a step function. You're going to see why here in a second. So what I want to do is kind of move this so that we have room for a graph. Okay, I'm going to label my graph very carefully. Here's the time axis,
down here. Up here is the cost in terms of time axis, or the y-axis. We're going to start out at 0 minutes and then go to 1 minute, 2 minutes, 3 minutes, 4 minutes, so on. Label this minutes down here because that's what it's in. Over here is cost. And it's cost in terms of cents. Or I suppose you could put dollars, but cents probably makes more sense in this case. Now, here's the deal. As soon as you pick up the phone and you start using the calling card, how much are you going to pay? How much are you going to pay? You're going to pay 50 cents. Now, if you never pick up the phone and you don't talk the phone, do you have to pay any money at all? No. But as soon as you pick up the phone, you're paying 50 cents. So anything between 0 and 1 minute, you're paying 50 cents. But at 0, you're not paying anything at all. So right there we put an open circle. And at 1 minute, we put a closed circle. Because at 1, you still pay 50 cents. But as soon as you talk past 1 minute, and you're at 1 minute and 2 seconds, or 1 minute and 1 second, you jump or you step up to what? You add 20 cents. So now you're at 70 cents. So you go up, step up, open circle, because at 1 minute it still costs 50 cents, but anything past 1 minute, up to 2 minutes, it's 70 cents. And guess what? After 2 minutes, you jump again, and you pay another 20 cents. And you step up. At 3 minutes, you still paid only 90 cents, but as soon as you jump past 3 minutes, you jump again, because now you're going to pay $1.10. Step, close your circle, and it just keeps repeating. The nice thing about a step function is once you get the first step or two, it's just a pattern over and over and over. Now, real quick, one little item of note, being that our increments were only 20 cents and the first increment was actually 50 cents, we need to break that right there. So put a little squiggly. Alright, so you just graphed a step function. Nice job. Let's talk real quick the domain and the range. The domain, T could be what? Alright, can you talk for negative minutes? No, so our domain is restricted. You could talk 0 minutes, I suppose. That's less than X, all the way up to what? How many minutes were on the calling card? What were we restricted to? Oh, that shouldn't be X, by the way. That should be T. You could talk all the way up to 30 minutes. And the range on this one is very fun. Okay, the cost, C of T, such that all C of T this range is a little difficult to display, so I'm going to let you cheat a little bit. We're just going to say C of T could equal 50 cents. Could it equal 55 cents? Could the cost equal? No, it couldn't. Or 70 cents, or 90 cents, or $1.10, or ... What if you talk for 30 minutes? 30 times 20 cents is all the way up to, if you talk for 30 minutes, I believe you're going to pay $6.50. I want to check me on that, but I'm pretty sure that's what you're going to do. So we'll just kind of cheat and write the range like that. There's probably a better way to write it, but I don't want to confuse you too much more than you already are. So I believe that's all I have for section 1.4. Very difficult section. Make sure you invest a lot of time into it, especially those step functions. If you have questions, feel free to text me or ask me in class. Hope things are going well, and I will see you later. I'm out.